Hello everyone, welcome to the second part video on circuit theorems. In this video, I'll be walking through numerous kinds of questions you can find in circuit theorems. Some are going to be simple, some are going to be difficult, some are going to be mid-range. Now, it doesn't matter what kind of question you find here. At the end of the session, you will have a better understanding on circuit theorems. So without wasting any of your time, let's dive straight into the first question. Now, here we have a diagram A, B, C, and D on the point of a circle with center O. Okay, center O here, and angle BAD is 55 degree, and BOD is X degree. Okay, and then angle BCD is Y degree. Now, in the first part questions, we asked to find the value of X. Now, this angle X here. Okay, to find the angle of X, now we can consider this angle of circumference here definitely has to be twice the angle here. So if here is 55 degree at the circumference, at the center it has to be twice of it, and then going to be 55 times 2. So to work out the value of X, I can say X is going to be 55, okay, degree times 2, and this is going to give me 110 degree. So angle X is 110 degree. Now the reason here, we asked to find the reason. So give a reason for your answer. Well, angle center, okay, angle center of a circle, okay, angle center is equals to twice angle at circumference. Okay, that's make it very easy. Conference, okay. Now for question B, it says work out the angle Y. Yeah, this angle Y, okay. And to find angle Y, you can consider two ways you could do that. One is to try to find the reflex angle here and then divide by 2 to get angle Y. Or you may consider that this is a cyclic quadrilateral. 55 and angle Y should add up to 180 degree. Now, any of these two steps you use, you arrive at the same answer. But I like to use the opposite angle of a cyclic quadrilateral. Okay, so that means 55 plus Y should give me 180. So to get Y, what I need to do is to say 180, okay, subtract 55 degree, and if I do the subtraction, I'm going to have 125 degree. Okay, that's very easy. So Y definitely going to be 125 degree. Okay, now question I says give a reason for your answer. Well, the reason is going to opposite angle, okay, opposite angle of a cyclic quadrilateral, cyclic, I hope I got the spelling right, good, cyclic quadrilateral, okay, add up to 180 degree. So that's very simple. Okay, so now we're going to move to the next question. Here we've got a diagram here, and that shows the center O, and ABC are points on the circumference. Now DCO is a straight line. Okay, so this is DCO on a straight line, and DA is a tangent. So DA is a tangent to the second, and angle ADO is 34. So that's 34 degree. And now we need to work out the angle AOD, and so this is AOD. Okay, so this is the angle we're really looking out for. Okay, I'm going to shade it to make you see it very clearly. Okay, now to find that angle, we need to consider some theorems. Now this is a radius and this is a tangent. Remember, we said for a tangent meeting a radius, it means always meet at 90 degree. That means this angle here is 90 degree. So if we consider this triangle here, that's angle AOD, 90 degrees plus 34 plus this angle should give you 180, because sum of angles of the triangle is 180. So what I'm going to do here right now is to say I'm going to add 34 and 90. Okay, I'll add 34 and 90. That's going to give me 124 degrees. I'm going to subtract that from 180 degrees, and that's going to be 124. I'm going to subtract, okay, and that's going to give me 8 minus 2 is 6, or it's going to be 5, okay, 56. So that means angle here is 56 degree. Okay, so this angle here is 56 degree. Okay, now of course here I'm 56 degree. Okay, put it here. Okay, now Question B says, what are the sides of angle ABC? Now, the angle ABC really refers to here. Okay, so this is the angle we are kind of looking at for. Now, to know what angle to look for, always check the middle letter in the given alphabet. That gives an idea what you're going to be looking at for. Okay, so if here's 56 at the center, at the circumference is going to be half of it. Okay, so the angle ABC is going to be 56 divided by 2, and that's going to be 28 degree. Okay, so this angle is definitely going to be 28 degrees. So okay, and for question I says, give a reason for your answer. Well, the reason is quite simple. Angle center, okay, angle at center is twice the angle, at the circumference. Okay, just make it very quick. All right, so that was very easy. So we now know the angles for ABC and of course the reason. Okay, so let's move on to the next question. Now we have a diagram here, and ABC are points on the circumference of the circle with center O. And AC is diameter. Okay, very, very instructional. AC is diameter. So question A is, write down the size of angle ABC. So I'm looking for the angle on B. So there's definitely this angle here, all right? Now, since I have been told that this is a diameter AC, and this is angle on the semicircle, definitely this angle has to be 90 degree. Okay, so it's a right angle really. So angle ABC, the size of it is going to be 90 degree. Okay, and the question that follows after it says, what's the reason for your answer? Well, it's very obvious. Angle of the semicircle is 90 degrees. So you can say angle at the semicircle, okay, semicircle is right angle. Okay, that's very easy. Okay, so let's move on to the next question. Now, angle DEF are points on the circumference of the circle with center O. Okay, we have it there. And angle DOF is 120 degrees. Now, we need to work out the size of angle DEF. Remember, your focus is on the letter middle between DEF, and that's angle E. So I'm going to look, this is where I'm looking at for angle DEF here. Okay, good. Now, so what I'm going to do here is, if here is 120 degrees, definitely this angle is going to be half of it, because angle center is twice the angle at the circumference. So this angle is going to be 120 degree divided by 2, and that's going to give you 60 degree. Okay, and the second part, give a reason for your answer. Well, angle center is twice the angle at the circumference. That's the angle at the circumference. Okay, so that's it. Okay, let me just wipe this out to make this a lot neater. Okay, all right, and now we move on to the next question. Now this looks a little bit complex, but it's very simple. But let's look at it first of all. First of all. Now BDE are points on the circle with center O. Now center O is going to be somewhere here. Center O. Okay. And ABC is a tangent. Okay, this is a tangent. And BE is a diameter. And angle DBE is 25 degrees. Good. Now the question says, find the size of angle ABD. ABD is definitely going to be somewhere here, because ABD. Okay. Now to find this angle, okay, one thing we can consider first of all is you could think this as a straight line, okay, and then you have your tangent. Now remember, these two angles, this angle, the tangent and the straight line here, should add up to 90 degrees. Okay, so this whole part here, okay, is 90 degree, and I know here's 25, and I need to find this angle. All I need to do is to subtract 25 from 90. Okay, so I'm going to do something like this here. So I'm going to do 90 degree minus 25 degree, and that's going to give me 65 degree. Okay, so this angle here, angle ABD, I'm going to show that so you can see it when I'm really referring to, especially. Okay, that's this one is 65 degree. And the reason, okay, the reason is very simple. You know, radius and tangent, radius to tangent is 90 degree. Okay, and then question B says find the size of angle DEB. DEB. All right, DEB is going to be somewhere here. This is the angle I'm looking at for. Okay, all right. Now this angle here is an alternate segment to this angle here. Okay, okay. So the angle DEB is definitely going to be 65 degree also. 65 degree also here. The reason angle on alternate segment is equal. Okay, alternate segment the segment angles are equal. Okay, that's very easy. So here's going to be 65. All right, so that's done. So we go to the next question. All right, in this diagram, ABC are points on the circumference of a circle with center O, and PA and PB are tangents to the circle. Okay, and the angle ACB is 72 degree, and then we need to work out the size of angle AOB. AOB definitely gonna be here. Well, that's very easy to find because if here's 72, and angle center is twice the angle made at the circumference. Okay, so here's gonna be 72 times 2. That's 72 times 2, and that's going to give me 144 degrees. So this angle here is going to be 144 degrees. The reason is angle center is twice angle at circumference, twice angle at circumference. Okay, good. Now for question B says, what are the size of angle APB? APB is actually the angle here. Okay, so we will look at for this angle here. Okay, I'm trying to give it a shade. Okay, good one. Now, one thing to find this angle APB, APB, that's this angle here, we already know that we've been told that this line tangent here and this tangent meet at P. That suggests that, remember the theorem we said that when you have two tangents drawn out to meet at a point, the tangents should be equal. Definitely that means this angle, this length here of the tangent here is equal to the length of this tangent here. Okay, that's very easy. Okay, and then another thing we need to consider, we have a radius that comes from here down here and meets a tangent that's going to be 90 degree. Or okay, the same another radius with another tangent here, that's going to be 90 degree. So we got three angles and then another angle here, APB. Now I know that I have a what you call a quadrilateral here, and if I add up these four angles, this, and this, I'm gonna have 360 degrees. So I'm gonna add these three angles first. 90 add 90, that's gonna give me 180, and add up 144 also, 144, that's gonna give me 324 degree. Okay, all right. Then to find this, I'm going to subtract this sum from 360. So I'm going to have 360 degree minus 324. Okay. Now, if you do the subtraction, and you're going to have 6 here, 4, 36. So this angle is going to be 36 degree. So that makes it a lot easier, right? Here we need to find the angle marked ABC, okay, for the different second terms problem you have here. Now, if you look at the first question here, we got angle made at the circumference 88 degrees, and we need to find the angle made at the circumference here, A. Well, this is going to be, if here's 88, because angle center is twice the angle made at the circumference. So if here's 88, angle A is then going to be half of it. So we're going to have 88 degree divided by 2, and that's going to give you 44 degrees. So angle A is 44 degrees. Then we'll come to question B. Okay, number 2. If here is 46 degree at the center, now you need to find an angle here, B, and the circumference. Okay, I mean at the circumference. Okay, so well, it's still the same thing. You're gonna have to 46 divided by 2, and that's gonna give you 23 degree. Okay, so here gonna be 23 degree. Okay, and so we come down here, up here, right, 23 degree. And then we'll come to question C. Okay, number 3. We need to work at the angles C at the center. If the circumference angle here is 46, at the circumference at the center, you're going to have twice of it. So it's going to be 46 degree multiplied by 2. That's going to give me 92 degree. Okay. All right. So here's 92 degree. So C, you're going to be 92 degree. That was pretty easy, right? So let's move on to number 4. Here we have a second theorem problem. Now we need to find the angle marked D. Well, if you really consider, I want to do something here to help you see what I'm seeing. If I try to move this line here, okay, you can immediately see that 23 is the same angle as D, angle on the same segment, right? But I'm going to restore it back, okay? I'm going to restore it back just to help us see. Okay, so if it's 23, D is going to be 23. Okay, so D is 23. The reason is because angle on the same segment are equal. Okay, and the same for number 5. The same thing. If here's 39, letter E should be also 39. Angle on the same segment. So letter E is going to be 39 degree. So come down up here, write down 39 degree here. But I need to find angle F. Well, to find angle F, there are a couple of ways you can do that. Okay, F here is going to still be the same angle here, okay, because this is going to be, you know, angle the same segment, okay. So I'm going to consider this triangle here. I'm going to add 39 is 85, and the result I'm going to subtract from 180. So let me try it here. 39 plus 85 degree. And that's going to be 4 here, carry 111, 12, 124 degrees. To find angle F, I'm going to subtract this from 180. Remember I did add here, so 180, subtract 124. That's going to give me 56 degree. So that means angle F is 56 degree. And that's in here. So angle F is 56 degree. Pretty very easy, right? And then we come to number 6. We got a drawing here, having an angle here at the center and an angle here at the circumference. Well, still the same. Angle at the center is always twice the angle at the circumference. So if here is 41 at the circumference, at the center it's going to be twice it. It's going to be 41 times 2, okay? And that's going to give me 82 degree. So angle G is going to be 82 degree. Okay, write it down. So I'll come up here, 82 degree. Very simple, right? Okay, let's move on. Let's see more. All right, we got as angle in the semicircle here, and O, this line here is a diameter. Okay, we set a O. Now this obviously angle in the semicircle is going to be 90 degrees. So angle H definitely has to be 90 degrees. Oh, there's no question about that. Okay. And the same for question 8, the same thing. You can say this line is the diameter passing through the center O, and this makes an angle at the semicircle. Okay, so the angle I definitely also going to be 90 degree. So angle here is going to be 90 degree. And then we'll come to question 9. Now, if you look at this question, you can see you got 2 lines passing through the diameter. Okay, through the diameter center O. Now, I already know that angle J is going to be equals to 36 degree because, well, that's going to be angle the same segment, okay? So I'm going to run 36 degree here, that's angle J, so 36 degree, okay? And to find angle K, I'm going to consider this triangle, okay? And this is diameter passing through center O, okay? So this triangle, that means this angle going to be 90 degree, definitely for sure, okay? Going to be 90 degree or half right in degree. So if I add up this 90 and 36 and subtract from 180, I'm going to get angle for K. So I go straight by adding 90 degree and 36. That's going to give me 126 degree. And this, I'm going to subtract from 180 to get K. So 180 degree, subtract 126. This is going to give me 54 degrees. So angle K is going to be 54 degree. That was pretty easy, right? All right, so let's move on to the next question. Question number 10. We got some second problem here, right? Good. Now we need to find angle L. Now the angle made at the center here is already 100 degrees. At the circumference, going to be half of it, okay? Because angle at the center is always twice the angle at the circumference. So angle L definitely going to be 100 degree divided by 2, and that's going to be 50 degrees. So L is 50 degree, and so put it up here, 50 degree. Next, we have to work out the angle M. Now, if you look at this question very well, you can find this is center O, and with a radius here, another radius here, okay, and in an equal, and if they're equal, it means the base angles should also be equal. So here should also be angle M, okay. Now I know the base angle should add up to, base angle should be equal for an isosceles triangle, okay. So to find angle M, I'm going to subtract, I'm going to do, or I can do something, add M and add it to 100 to give 180, right? Or for M, or you could just say 180 minus 100 and divide it by 2 to get one of each of angle M, okay. But I'm going to use that method. I'm going to say 180 here, subtract 100 degree, and that's going to give me 80 degree, okay. Now this 80 degree, I'm going to divide it into 2 to get each of the angle for M, going to be 40 degree. So here's 40 degree, M is 40 degree, and here is going to be also be 40 degree. Okay, so M is 40 degrees, so I come here right down here, 40 degree. Okay, all right, we come to question 11, and we got some really complex problem here, but we can really do some working here. We need to find angle N, P, and Q. Which one can we get first? Yeah, we can get N, okay, because have angle at the center here is twice the angle of circumference here, okay. So N definitely gonna be 18 times 2, and I'm gonna give you 36 degree. So N is gonna be 36 degree, okay. Quite one, an easy one. Next, to get angle P. Now, how do we get angle P? Now, this is angle P here. Well, that's very easy, because see, this from here, from center O down here is a radius, and same from center O here to other here is also radius. So that means this length here should be equal to this length here, and that's going to be an isosceles triangle. Okay, and that means this base angle here should also be angle P. Okay, I already know N is 36 degree. All I need to do is to subtract, to find angle P is to subtract this angle 36 from 180, and then half it to find individual angles for P and this other angle here, virtual P. Okay, so what I'm going to do first is to say 180 degree minus 36 degree. It's going to give 4 5, okay, 104 degrees, okay. Then to find each angle P here and this also this virtual angle P, I'm going to divide 144 divided by 2, and that's going to give me 72 degree. So that means angle P is going to be 72 here degree, and also here this angle P here is going to be also 72 degree. So I come here, right, angle P is 72 degree. And next we need to find angle Q. Well, there are a number of ways you can find angle Q. One way you could do this is, a very fast way to do that is, I already know that PQ, this add up these two angles here should always be equals to 108. I mean, these two angles P and Q and 102 add up to 180, right? Because it's cyclic quadrilateral, okay? All right, so what I'm going to do here, I'm going to say P plus Q, okay, this is an angle, add up to 102 degree, that's going to be 180 degree. Why? Because this is the opposite angle of a cyclic quadrilateral, because we have the quadrilateral here already in a second. Now I already know angle P to be 72, so I have 72 plus Q plus 102 is equal to 180 degree. Now if I add up 72 plus 102, I'm going to have 174 degree, and let's go to 180. And to get angle Q, you subtract 174 from 180, and that's going to give you 6 degree. Okay, 6 degree. So that means angle Q is actually 6 degree. Okay, now in this question we need to find the various angles A, B, C, D, E, and F. But first, angle A. Now this is a cyclic quadrilateral, okay, in a cycle, okay, and we need to find the angle A. Remember, the opposite angle of a cyclic quadrilateral always add up to 180. So to find angle B, I'm going to find the angle A. Let me get angle A first, okay. Angle A is going to be 180 degree, or subtract 109. Okay, then this is gonna give me subtract gonna be 1, okay, 7, so 71 degrees. So angle A is 71 degree. Okay, A is 71 degree. To work out angle B, I'm going to subtract 188 from 180, okay, and that's gonna be 9. Correct. So angle B is going to be 92 degree. So B is 92 degree. All right. For this, another cyclic quadrilateral, the opposite angles always add up to 180. Okay. So angle C then is going to be 180. C and 120 should add up 180. So to get C, 180 minus 120. And that's going to be 60. So I'm going to see 60 degree. Okay, so C 60 degree. For D, the same thing, go do 180, subtract 103, 113 rather, 7, 67. So it's going to be 67 degree. So D is 67 degree. But if you add them up, you're going to see they're going to have 180 degree. So this is going to be 67 degree. And then we come to question 3. Now we need to find angle E. Okay. All right. To find angle E, well, you can consider this line here is a straight line, and the standard angle is 98. Now to find this angle here, I'm going to do 180 minus 98. Okay. Let me do 180 minus 98. It's going to be equal to. That's going to be 82 also. Am I right? Good. 82. So they're going to be 82 degree. All right. And to find angle E, this angle add up E and they should give you 180. So to find angle E, I'm going to subtract 82 from 180. So let's do 180 subtract 82. Okay, you have 8 here, and they could have 9, so 98. So this angle E is going to be 98 degree. So here's 98 degree. To find angle F, well, we've got opposite angle of cyclic quadrilateral should add up to 180. So I'm going to find angle F. I'm going to subtract this value 125 from 180. So 180 degree subtract 125. That's going to be 55 degree. So angle F is going to be 55 degree. Okay. Now, just out of interest, if you add up this opposite angle, you'll find the values add up to 180. The same for this and the same for this also. Okay. All right. So let's move on to the next question. All right. We need to find angle GH. Okay. Here to find angle G or angle H, but let me say angle. Let's say angle G first. But I know you have a straight line here. Here's 100 degrees. Here can be 100. 180 subtract 180, so you're going to be 80 degrees. Okay, because angle of straight line is 180. Okay, so if here's 80, this angle, both angles should be equals. G and 80 should add up to 180. So this G is going to be 100 degree, because you're going to do 180 degrees minus 80. Of course, it's going to be 100 degrees. That's how I got this 100 degrees here. So angle G is 100 degree. For angle H, well, one thing I can tell is that this angle here is going to be, to find this angle here, I'm going to subtract it from 180. So 180 minus 85, 5. So here's remaining 7. So 7 minus in the positive, so here 17 minus 8. That's going to give you 9. Okay, of course here is 0 anyway, so 95. So it is going to be 95 degree. Okay, and to find angle H, remember angle on a straight line is 180. So H is going to be 180. 180 minus 95. Again, you have 5. Subtract. And you have 85. Okay. So angle H is going to be 85 degree. So angle H here is 85 degree. And then we come up here. Now we need to find angle I. Here, this angle I. Now we've got a triangle here already. We know that this length here is equal to this length here. That means the angle I here should also be equal to the angle I here. Okay, but let's continue. But again, you have a straight line here, and this angle here, these two angles should add up to 180. So if here's 102, this angle is going to be 78. Okay, 78. And how do I know it's 78? All I need to do is to subtract 102 from 180, and of course that's going to give you 78. Okay, so if here's 78, I can actually get here. Okay, because I have opposite angle of a cyclic quadrant added to 180. Okay, so I'm going to do 180 subtract 78, and I'm going to see have 102 here, because these two angles now should add up to 180. Now to find angle I, okay, I have two base angles here which are equal. All I need to do is to subtract 102 from 180, and the result I get are divided by 2 to get individual angles for the base angles here of the triangle. Okay, so what I'm going to do here, I'm going to do something like 180 subtract 102, which will give me 78. Now this angle 78, I'm going to divide it by 2 to get individual angle here. So I'm going to do 78 divided by 2. That's going to give me 39 degree. So angle I is going to be 39 degree. Okay, also here also going to be 39 degree. Now if you add up this triangle, you're going to find, if you add up these angles, you're going to find it's going to give 180 degrees. So angle I is 39 degree. And then we come to question 6, and we got a kind of a drawing here, and we need to find angle J. One of the things you could do is, there are a number of ways you could do. You could find this reference angle here and then divide by 2 to get angle J. Okay, or you could just think of this angle here to be 44, because angle center is going to be twice the angle circumference. So if here is 88, definitely here has to be 44. Okay, And then I can now consider that this angle here and angle J add up to 180 because you have a cyclic equilateral. Okay, so that means I'm going to do 180 minus 44 6 is going to give me 36 degrees. So angle J is going to be 136 degrees, because if you add up J and this angle here, I'm going to give you 180. So angle J is going to be 136 degrees. This is not the only way, but you can solve this. Okay, like I said, you could find this angle here by subtracting 360, and then whatever you get, you also divide by 2, you get the angle J. All right. Okay, so let's move on to next. We got some real difficult question here. We know lots of have a problem trying to figure out how to solve this problem. But let's try it. Here we got a center, okay, with center a diameter here with center O. All right, and we know this length here is equal to this length here. And I also have a radius here, another radius, meaning that this length here should be equal to this length here. All right. Okay. So to find angle M, well, because we already know that it's a diameter and this angle semicircle, that means that this angle actually going to be 90 degrees. Okay. All right. And to get this angle M, all I need to do is subtract 90 from 180. Whatever I get, I half it. Okay. So I'm going to have 180 here minus 90, because this angle here is definitely going to be equal to M. Okay. All right. So if I subtract this, it's going to be 90. Okay. And then if I'm going to have this, you're going to have this 90 divided by 2. I'm going to have 45. So angle M going to be 45 here, and also here going to be 45. Okay. If I really want to write it down, okay, it means the same thing. 45 degrees here, 45 degree also here. So angle M is going to be 45 degree. Okay. Next, we need to work out angle K or L. Now, one thing you can consider here is that okay, I'm trying to see what I'm going to do. Let me try to shade it here. Okay, let me see what I'm going to do here to find either, well, if this angle K, here also has to be angle K, right? Yeah, it makes some sense if you say so, because this length here is equal to this length, and so the base angle of triangle should be always be equal. So we need to find angle K or L. All right. One thing you can consider, which is very easy, if here is an angle here is 90 as circumference, I need to find an angle at the center. All you need to do is multiply by 2, right? Okay. If here is 90, a circumference going to be 180. Okay. All right, but I don't think that's going to work. What I can do here is I'm just trying to figure out what I'm going to do here. Okay, good. These two angle here, okay, this two angle here should equals to this two angle here, because I mean they should add up to 180. Remember, angle opposite angles of the cyclic quadrilateral are always 180. Okay, so this angle here and add this angle here should give me 180. So what I'm going to do is to say I'm going to add up these two angle. I'm going to put it like this. These two angle here, which is 45 and 34. Okay, and add up to this angle here, which is 45 plus K. Okay, should give me 180 degree. Okay, so if I add this value, these two here, I'm gonna have 79 degree plus 45 plus K is equals to 180 degree. And if I add this, I'm gonna have 4 here, 124 plus K is equals to 180 degree. So get angle K is definitely going to be 180 minus 124, and that's going to give me 56 degree. So angle K is 56 degree. Okay, so K is going to be 56 degree. Okay, all right. So to get angle L, get these two angle KK and L should add up to 180. So 56 plus 56, subtract it from 180 to get angle L. So I'm going to do 56 degree add 56 degree. That's going to give me 112, and I'm going to subtract that from 180. So 180 subtract 112. Okay, that's going to give you 68. So angle L is going to be 68 degree. That was pretty very kind of difficult. Okay, all right, so let's move on to the next question. Number 8, we need to work out N, P, and Q. You can see the center O, okay, the diameter. All right, what you know here going to be 40 degrees. Okay, you know why? Because we got vertical opposite angle. All right, so how do we find N, P, or Q? All right, well, definitely, because since this is a diameter and have angle in the semicircle, this angle is definitely going to be 90 degree. Okay, so I'm going to shade it. I mean 90 degree. All right, so to find angle P is very easy. Just consider this triangle here. Okay, so I have 90 plus 40 and 90 plus 40 here. That's going to be 130, and subtract it from 180. So 180 subtract 130, and then 50 degree. So angle P is 50 degree. So angle P is 50 degree here. All right, so we need to find angle N and P. Another thing you can consider, you got a straight line here. So if here is 40 degree, then we can also find here, which is going to be, okay, going to be 140, right? Because these two angles should add up to 180. All right, so if I consider this triangle here, I have 140 plus 21 plus N should be add up to 180. So what I'm going to do to find N is to add up 140 plus 21. Okay, I'm going to do it here. 140, okay, that's going to be too far. Okay, let me take that away from there. Let me do the work in here, somewhere here. So 140 plus 21, that's 161. Okay, I'm going to subtract it from 180. So 180 minus 161, and that's going to give me 19 degrees. So N is going to be 19 degrees. So N is 19 degree. All right, so 2 down, remaining 1, which is Q. To find Q, what we may consider here is okay, the angle Q is also in the same segment with P. So if P is 50, Q has to also be 50 degree. Okay, that's very easy to spot. All right, so we come to one more question, number 9. We need to find angle RS. Now we know that we have 2 lines marked, okay, meaning that they are the same. So definitely this angle here is going to be angle R, really. Okay, so what we can do, we know if here is 134, we can also find here, because the sum up to 180. Okay, so opposite angle of a cyclic quadrilateral is 180. So I'm going to find 180 minus 134 here. There's going to be 46. So this angle here is going to be 46 degree. Okay, and to find angle X, well, I can also think that this angle here and angle S should add up to 180. Angles, opposite angle with cyclic quadrilateral add up to 180. Okay, so angle S definitely going to be 180 minus 110. Okay, that's 70. So angle X here is actually 70 degree. The full angle here is 70 degree. Okay, so S is 70 degree. And then I need to find angle R. Well, That's very easy. Like I said, this angle here, this angle I'm going to shade, that's what I'm referring. Okay, angle R plus angle R plus 34, 134 will give 180 degrees. So if I add up, what I'm going to add 180. So what I'm going to, one easy to get angle R is to subtract 134 from 180. Okay, and that's 6, 46, and then divide by 2 to get the individual angles for R here and the other. So 46 divided by 2, this is going to give me this is going to give me 23 degrees. So R is going to be 23 degrees. Wow, that was real tough. Okay, so let's move on to the next question. All right, so we need to work out the angle A. Now this is alternate segment. They're always equal. So it's here is 64. Here has to also be 64 degree. Very easy. Okay, alternate segment are equal. And the same for here. If here is 51, angle B has to be 51. Alternate segment are equal. Okay. And then to find angle C, you can think of these three angles. You add up 180 angle in the triangle. So I'm going to add up 51 and 63. 51 add 63. That's going to give me 114. And to get the angle C, I'm going to subtract this from 180. That's going to give me 66 degrees. So angle C is 66 degree. All right. Okay, so now we move to the third question. So we need to find angle D and E. We have a tangent drawn here, and we've got a cyclic quadrilateral here, and these two angles D and 88 should add up to 180. Opposite angles of a cyclic quadrilateral also add up to 180. So then I get angle D. All I need to do is to subtract 88 from 180 degrees. I'm going to have 92. Okay, yeah, 92. So angle D is 92 degree. Okay, so D is 92 degree. Next we have to work out the angle E. Well, it depends on what you're looking at, but if you kind of turn this around, you'll immediately see that this angle here is alternate segment to E. I mean, that's it. So E is going to be 28 degree because alternate angle are equal. All right, that's very easy, right? Good. All right, so let's move on to the next question. We got a circle and a triangle inside here and a tangent, and this triangle, the length here is equals to the length here. Okay, meaning if here's F here, there will also be angle F because the base angle of an isosceles triangle are always equal. Okay, so if here's 78, angle F definitely has to be 78 because the alternate segment angles are always equal. So F is going to be 78 degree. To find angle G, I need to add up these three angles to add up to give me 180 and the final angle G. Well, here is 78 anyway. We know that because the base angle are equal. So out of 78 and 78, I'm going to have 156. To get find angle G, I'm going to subtract this from 180 because we have some of angle triangle is 180. So 180 subtract 156, you have 24. So angle G is going to be 24 degree. Okay, yeah, 24 degrees, somewhere around 24 degree here. So here going to be 24 degree. We're making good progress, right? Okay, now for number 5, we need to find angle H and I. All right, but first I know this angle. This angle I definitely going to be the same angle here. Okay, so if I know this angle, that's going to be angle I because we have alternate segment. All right. Well, one way we can do this is to think of the sum of angle of the triangle is 180. So if you have 65 and 50 here, what's going to be angle here in the triangle? So I'm going to add 65 and 50, and that's going to be 115. To find this angle here, I'm going to subtract this from 180. Okay, if I subtract this, I'm going to have 65. So this angle is going to be 65 degree, and angle I is alternate segment to angle I, and the always angles are always the same, so angle I is going to be 65 degree. Already we already know that this angle 50 degrees is alternate segment to angle H, so H is going to be 50 degrees as well. Okay, all right, so we move on to question 6 now. We got some angles J, K, L, M that we need to find. We're going to have a triangle here, eclipse with a circle, and then you got a tangent here. Now, one thing we know about an isosceles triangle that they are always, the base angles are always the same. So if here is 40, because we have this right here, okay, so here is 40, the base angle K also has to be 40 degree, so K is 40 degree. Okay, and I know that this angle is the L. Yep, angle L is alternate segment to angle 40 also, so here is going to also be 40. Okay, so that's going to be 40. Alternate segment are equal. All right, now we've got a straight line here. Okay, now these three angles should add up to 180. Okay, so if here is 40 40, to get here J is going to be 100. Okay, because you see they should add up to 180. Okay, right, let me just show you the working. 40 plus 40, that's going to give you 80 degree, right? And remember, these three angles should add up to 180 because angle straight line is 180. So I'm going to subtract this 80 from 180, and that's going to give me 100 degree. Okay, so angle J is 100 degree, and this angle is also going to be alternate segment to M. They should have the same angle, so it's going to be 100 degree as well. Okay, all right, now you might have noticed that you could go to angle M another way by thinking that you have a triangle here. Okay, these three angles should add up to 180. So if here is 40 40, that's 80. To be 180 in a triangle, subtract 80 from 180, you're gonna have 100. Okay, so that's another way you could want to solve that. Okay, all right, so we move on to question N. Here we got notice that we have a segment here and a radius. Okay, meaning that this whole angle here must be 90 degrees. But first, let's not go through that route first. Okay, first thing, we got a radius and another radius here. That means the length here should be equal to this length. Okay, and the angle here should always be also be equal to the angle here. Okay, this angle here, the base angle here should also be equal to the base angle here. So to find each of the base angle, all I need to do is subtract this from 180. That's 180 minus 162. If you subtract that, that's going to give you 18. Okay, so to find each of the base angle here, divide this angle by 2, and that's going to give you 9 degrees. So each here is 9 degree. Also here is going to be 9 degree. Okay, and I always also know, as like I said at the beginning, that here this is radius. I have a diameter. I mean a tangent. Now a radius means a tangent at 90 degrees. So this whole angle here is 90 degree. So if here is 9, n is going to be 90, take away 9, and that's going to be 81 degrees. So n is going to be 81 degree. That's pretty easy, right? And then we'll move on to question number 8. Now we need to find angle P and angle Q. Now we have this could I have a tangent here drawn here, a tangent drawn here also, meaning that this length here should be equal to this length here. So if you look at this triangle here, here going to be angle P also, because they're going to be the same. So to find angle P, okay, you subtract 76 from 180. Okay, that's going to be 104. So to find each angle here on the base of the triangle, divide this value, okay? 104 divided by 2, that's going to be 52 degrees. So each angle here is 52 degree, and here also 52 degree, okay? Okay, this is going to be 52 degree also. So we know P is 52 degrees, so write down 52 degree here. Okay, now we need to find angle Q. Now to do that, one thing we can think of is since this is center and this is a radius, this length should also be equal to this radius here. So here has to also be angle Q also, right? By extension. All right, so but what we know is this: to get angle Q, all right, remember we could do something like here's 52, here's 52, okay? I'm just thinking how I'm gonna work this out. Okay, all right, okay. Also, I also know that this, since this is a radius, okay, and you have a tangent also, this whole angle has to be 90 degrees. That's a very smart one, okay? 90, okay? Remember, a radius means a tangent at 90 degrees all the time. So this angle has the whole angle here. You can see when my pen is moving, the whole angle here is going to be 90, meaning that angle P and Q add up to 90. So to find angle Q, you subtract 52 from 90. So 90 minus 52, that's going to give you 38 degrees. So angle Q is going to be 38 degree. So angle Q is 38 degree. That was very smart, right? Good. And let's come to question number 9. We need to find angle R, S, and T. Okay. And we have the center, and then we got a radius, and we have a tangent. And we know the radius makes an angle of 90 degrees with the tangent. So that means angle S plus T definitely has to be 90 degrees, right? Okay, that's it for sure. And because this is a radius, okay, for coming from the center, and also here, this angle 2 is going to have to be angle S also. Okay. So to find angle S, all I need to do now is this triangle should give you 180 angle in the triangle. So all I need to do is to subtract 40 from 180. So 180 minus 40, and that's 140. And to find angle S, each of the angle S here, I'm going to divide it by 2. So 140 divided by 2, that's going to be 70 degrees. So angle S is 70 degree here. Okay, 70 degree. Let me write it very well. So angle S is going to be also 70 degrees, but I don't have to rewrite it. Okay. Angle S is going to be 70 degree. And remember, we said S plus T. This angle, two angle are going to be 90. So if S is 70, T is going to be 20, because 90 minus 70 is 20. So angle T is going to be 20 degrees. So that's 90 minus 70, and that's 20 degree. So angle T is 20 degree. Now to find angle R, you can consider this full triangle, okay? And remember, the angle sum of a triangle add up to 180, and you'll have your total 90 plus 40. 90 plus 40, that's going to be 130. And to find angle R, okay, I'm going to subtract from 180, so I have 180 minus 130, okay, that's going to be 50 degrees. So angle R is going to be 50 degrees. That was really, really hectic. Okay, so we come to the last question, number 10. Wow, wow, wow. Now we got a cycle, we got 2 tangents and a triangle, also with 2 legs equal, okay? And then we need to find angle VU and W. All right, let's see what we can do. First, we know here gonna be 81. Why? Because these two legs are equal, so the base angle should be equal. Okay, so it's easy for me to find angle U because I have a triangle. This triangle add up to 180. So to get angle U, add 81 plus 81. Oh, did I say one? Sorry, that's gonna be 162. And to get angle U, subtract this value from 180, and that's gonna give me 18. So angle U is gonna be 18. 18 degree here. So angle U is going to be 18 degree. Next, we need to work out the angle V and W. Now, already we know that we've got a tangent here, another tangent here. This length here should be equal to this length, meaning that this angle V should also be, this angle here should also be angle V, because they should be equal. Base angle are always equal. Okay. Now, we already know that if this angle V is alternate segment to this angle here, so V here is going to be 81. That's quite very sleek. Okay, so V is 81 degree here, and if it is 81, this angle here also has to be 81, because remember, these are base angle of this triangle. Okay, so to get W, add up these three angles to be 180. So to get W, I need to add these two angles first. That's 81, add 81, 81, add 81, that's 162. And to get W, I'm going to subtract this value from 180, because remember, there's some angles in the triangle is 180. So 180 subtract 162, that's going to give me also 18 degrees. So W is 18 degree. Wow,